Hi friends, how are you all? Today we will discuss electrolysis. Electrolysis means it is the process where the electrical energy can produce chemical changes. Okay, let us see how this happens. So generally, for example, if I have taken one small beaker, for example, I have taken a beaker and I have taken some molecules. So all the molecules and all the atoms are tightly bound in nature. That's why they are existing in stable state. Okay, so they are tightly bound. And what happened if I pour some water on it, or when these molecules or when these materials are dissolved into some liquid, whatever may be, maybe it may be even water also, some liquid, then what will happen? The bonds between the atoms become weaker. They become weaker. And now if we give the electricity, that electricity is sufficient to break that into some ions. Okay, to break that into some ions, let's take these explanation little forward by taking one more bigger beaker. Okay, same thing I poured in here and it is a dissolved state. That means it is like a liquid state or molten state. Okay, now I want to use two electrodes. This is one electrode. This is one electrode and this is another electrode. Now I want to connect these two some battery, and this is the DC supply I am giving here. This is positive, so this anode is connected to, sorry, this electrode is connected to positive, so that's why this is called anode. This is called anode, and this is connected to negative terminal, so this is called cathode. Now what exactly happens? So because of these things, I mean because of first what we have done, we have taken some certain material and we have dissolved that material into a liquid. Then what will happen? The bonds among them are weaker, and now finally we are applying the electricity also. So because of this electricity, what will happen? This electricity is sufficient to break them into ions. Now if those ions are, for example, those ions are of two types. One is cations and anions. So definitely if we break anything, they will convert into either cations or anions. Cations means these are the ions with positive charge, so positively charged ions, and anions means negatively charged ions. So according to the principle, okay, opposite poles attract each other. So these positively charged cations attract towards cathode and negatively charged anions attract towards anode. So in this way, there is a flow of electricity, and because of this cations, okay, which are deposited at cathode, they are generally useful and they become, see, cations means positively charged, that means they are lacking of electrons, and they will take those electrons from cathode, and they will become atoms, that to pure atoms. Okay, so these are deposited at cathode only. These are deposited at cathode. Now we will see with an example also. Let me take CuSO4 as an example. CuSO4. CuSO4 is the material here, and we are dissolved this material into any liquid. Maybe let me take water only. Then what will happen? So this CuSO4 becomes Cu plus plus and SO4 minus minus. So they while we are giving the electricity, that CuSO4 is divided into two ions. One is Cu plus plus and second one is SO4 minus minus. And Cu plus plus is attracted towards cathode, and SO4 minus minus is attracted towards anode. Okay, then SO4 minus minus is having more electrons, so it releases these two electrons in the anode, and Cus plus plus is having two electrons lacking, so it is taking those two electrons from the cathode and it become Cu, and so this will be converted into Cu plus plus and SO4 minus minus. So CuSO4 is going towards, attracted towards cathode and take two electrons from cathode and it become Cu atom. Okay, but SO4 is also, it is having excess of electrons and it is giving these two electrons to this anode and it will become SO4. But the problem of SO4 is SO4 is a free radical. It won't exist simply. Okay, it has to collaborate with some other elements only. So based on the anode, it will, the action will be there. For example, if anode is made up of copper, if the anode is made up of copper, then it will become copper sulfate, CuSO4. If the anode is not made up of copper or any material which is not unable to collaborate with SO4, then this SO4 will be collaborated with water only, and it will be like this: SO4 plus H2O water, it will give us H2SO4 plus O2 oxygen. So if you make it balanced, it should be 2 SO4 and 2 H2O, and it will be 2 H2SO4 plus O2. So it will, I mean, H2SO4 will be deposited here at anode and O2 will be liberated out. Okay, so this is the actual process of electrolysis with example. So if you like this video, please like and please share with your friends and family, and kindly subscribe to my YouTube channel. And I want to complete this electrolysis completely with so many things, maybe basic principles, Faraday's laws of electrodeposition, what is different items also. And now I want to discuss the applications of electrolysis. Coming to applications of electrolysis, applications. As we are getting pure metals here, I mean pure metals here, so we can use it for extraction of metals. And let us see some of the examples of those metals also. Yeah, the first one is extraction of metals. Extraction of metals from their ores. Extraction of metals, and the basic examples are aluminum, zinc, copper, magnesium, and sodium, etc. Sodium, etc. So these are the extraction of metals. By using electrolysis, we can extract these metals from their worse. And the second one is manufacturing of various chemicals, manufacturing of various chemicals. So in the previous case, we can manufacture H2SO4. So in that way, we can manufacture different types of chemicals. So in the previous example, we can say that we can extract copper metal in the previous example, and we can manufacture H2SO4 also. Okay, in that way we can take these two as the applications. So what we can do here, caustic soda, the examples are like this: caustic soda, potassium permanganate, potassium permanganate, hydrogen, oxygen, hydrogen, oxygen, etc. So these are the things we can, these are the chemicals we can manufacture from the process of electrolysis. And next very important application is electrodeposition. Electrodeposition. An example for this electrodeposition are, I mean, different types of electrodepositions are electroplating, electroplating, electrotyping, electroforming, and so on. And the final industrial application is building up of worn out parts in different industries like metallurgical industries, metallurgical and chemical industries, and some other industries also, industries. So these are the basic applications of electrolysis. Okay, and I will continue teaching electrolysis till the end, and here we can concentrate on extraction of metals. We will discuss extraction of metals, and of course in that process only we can manufacture some chemicals also, as we are trying to extract copper in the previous example, but we can also able to manufacture oxygen and hydrosulfate also. Okay, H2SO4, sulfuric acid, and electrodeposition also we will study, electrodeposition, electroplating. Okay, all those things also we will study in this course. So please follow me, and please subscribe to my YouTube channel, and if you have any doubts, please put in the comment box so that I can answer you within 24 hours. Thank you so much.